In this video, we are going to try and take some information about our hyperbola and come up with an equation for it. So they have to give you some information about whether it's a hyperbola. Most likely, if they give you the foci, if the foci are outside of vertices, and it's got to be a hyperbola because the foci on an ellipse are on the inside. But most likely, they're going to tell you that it's a hyperbola. And I like to build a graph to try to help me figure out my equation. So if I have a graph or I don't have a graph, I'm going to rough sketch or take advantage of the fact that I have an actual grid here. So we have vertices at 0, -3, and 0, 3. So we have vertices here. And your vertices only show up on the points of your graph. So the fact that your vertices are vertical, that means our graph is going to be vertical. What role that plays is whether I'm going to have x squared minus y squared or y squared minus x squared. So since it's vertical, I'm going to have y squared minus x squared. And right smack in the middle is my center. So my center is at 0, 0, which means we are having y squared minus x squared. I don't have any kind of a plus or minus thrown into this. So what I need to know is the up and down, which we already know. That value is 3, so the b value is 3, which makes the b squared value 9. And then I need the a value. So they tell me the foci. So the foci are at 0, 5, 0, -5. Well, that is my c value. So my c value is 5, so that means my c squared value is 25. And to find focal points, you would have done c squared would have equaled the sum of your denominators. So I just plug in what I know. I don't know my a squared, but my b squared is 9. So if I solve for a squared, because I don't need to square root it because I need this piece is going to be a squared in the equation, I subtract 9 over, and so 16 is my a squared. Wonderful. So 16. And that is everything I need for the equation. Technically, the graph would have went out left and right 4. 1, 2, 3, 4. And then 1, 2, 3, 4. And then I would have built a box. And the box is so I can line up my asymptotes. And then my graph would have been vertical, so it would have done something like that. Okay, second one. Second one gives you a vertex. All right. So that vertex is at 2, 0. Okay, now maybe it's horizontal, but it could be vertical. I don't know. My equations of my asymptotes are y equals 3/2 x. So that's actually an up 3 over 2. So 1, 2, 3 over 2. 1, 2, 3 over 2. And then my b value is actually right here. So if I graph this other one and I go down 3 over 2, what that's perfectly lining up for me is the corners of my box. So it also tells me that my center, because when I do my asymptotes here, your center is going to be at 0, 0. And my vertex is here, which means my graph is horizontal, which means it's an x squared over something minus a y squared over something. It's going to equal 1. Well, my x are my a's, so that's just my left and right 2. So if my a is 2, my a squared is 4. So that's the denominator for that one. And then my b value is 3. So if b is 3, b squared is 9. And that is my equation. The only thing visually I'm missing would be my other side of the horizontal graph. Now, there's danger in this slope here. because that 3 and that 2 just felt like, oh, that was perfect. 3 is my b and 2 is my a. Well, realize that that slope could have came from a 6/4 x, or it could have came from a 9/6 x. So you don't know that this is perfectly your b value and this is perfectly your a value, because it might have been something else that simplified to that. Because maybe you were actually up 6/4, but the slope simplifies to 3/2. So it's going to be a multiple at minimal of 3/2. It could very well be 3/2 for your a's and your b's, but it's not always going to perfectly match. Sometimes it will. We got lucky on this one, but not always, because it could always be something else that it originally came from. All right, so that was 2 examples of finding the equation of a hyperbola given just some different information.